Hello everyone, my name is Dan the Tutor, and today we're going to be looking at the 5 ways to evaluate limits by hand. The 5 ways to evaluate limits. And so last time we saw how to solve limits by graphing them and looking at the graphs and determining if it approached the same value from both sides. Today we're going to be talking about the 5 ways to evaluate limits if it has some kind of function notation. And here's what I mean. If we have a limit such as limit as x approaches 1 of 5x minus 6x squared plus 10. So the biggest difference between limits by graphing them and limits by hand and like the actual function is that with graphing them, you can just look at the graph, you can see if it approaches one side or the other. But whenever we have an actual function that we can plug x into, the first thing we can do is just try plugging in x into the function. And so here's what I mean. The limit here is literally going to equal 5 times 1 minus 6 times 1 squared plus 10. So we're literally going to plug it in verbatim. And what we get is 5 minus 6 plus 10. So we get a final answer of 9. So that's going to be the limit for this question. Now, that seemed a little too easy, don't you think? You know, limits don't really sound that challenging. Okay. Well, in that case, I have a follow-up question for you. What is the limit? What is the limit as x approaches 3 of 1 over x minus 3? Okay, well, if we just plug in directly, we get 1 over 3 minus 3, and we get 1 over 0. Okay, so now we have a problem, don't we? We can't divide by 0, and that right here is an essence of why limits can be challenging. And by the way, 99% of problems are not going to be like this because these are too easy. And most limit problems are actually going to look something along the lines of this, where if we plug in x, we get a 0 in the denominator, and we can no longer compute the limit. Now, this is not the end of the world. The limit can still exist in this scenario, but now we need to talk about some tools of how we can solve limits whenever this happens. So here we go, the 5 ways to evaluate limits. Take notes, everyone. The first method we're going to use, and you should always at least think about this in the back of your head, is using direct substitution. And direct substitution is exactly as it sounds. It was actually the same thing as that first example where we had 5x minus 6x squared plus 10, where we can just directly plug it in. Method 2 is going to be factoring and canceling. So factor and cancel. And let's see an example of that. So let's say we have limit as x approaches 0 of x squared plus 5x all over x. Okay, we can't plug in 0 here because we would get 0 in the denominator, but what we can do is we can try and factor out an x term in the numerator to cancel it with the x in the denominator, and then hopefully be able to compute the limit. Okay, so let's try that. What can we factor out of the numerator? Let's see, we can factor out the x, and we would be left with x plus 5 divided by x. Now, one of the super important things with any limit by hand is that we need to bring this limit notation along with us in every step of the problem. I know it's annoying, but this is like this is the correct thing to do. This is proper English, but for mathematics. And so we need to include the limit notation in each step, and this is what it looks like. Okay, now we see that the x's cancel, great. And what are we left with? We're left with still limit as x approaches 0, and now all we have left is x plus 5. One more thing on notation, if you were to write this, technically this is also wrong because what you're saying is the limit as x approaches 0 of x and then plus 5, which although it would be the same thing in this scenario, you really want to include the parentheses here, so you're saying the limit of the quantity. After we do factor and cancel, we can go back to step 1. Can we use direct substitution here? Well, let's try it. We get 0 plus 5. We don't have a 0 in the denominator. That's perfectly fine. So there we go. We have found this limit. It is 5. So whenever it comes to factoring and canceling, we're looking to cancel out a term in the denominator so that we're no longer getting 0 in the denominator, and then we can use direct substitution. So going back to our methods for finding limits, that was method 1, method 2. Method 3 is going to be rationalize and cancel. And if you remember what rationalizing is where you multiply by the conjugate, specifically whenever we have a square root sign. So an example, if I have x plus 1 minus 5 over just something like 3x, rationalizing would look like square root of x plus 1 plus 5 divided by square root of x plus 1 plus 5. And always the strategy here of doing this is to try and get rid of the square root. And so what we would have here would then be x plus, we would have to FOIL it. So we think about this quantity and we FOIL it with each outside, inside, first and last. And what we would get for the first term is square root of x plus 1 quantity squared, which if you think about it, the square root sign and the squared is just going to cancel out, and we're left with just x plus 1. Then we get plus 5 square root of x plus 1. Then we have minus 5 square root of x plus 1, and you can see these are just going to cancel out here, which is nice. And then for the last terms, it's going to be minus 5 times 5, which is just 25. Okay, and then the denominator, what we're going to get is 3x times the quantity x plus 1, now plus 5. And you can distribute that if you want, but generally that's not going to help you, because the reason why we did this step is because after rationalizing and canceling, you're pretty much looking for a factor and cancel, and then once again direct substitution. So let's look at an actual example now and see what that looks like. So I have the limit as x approaches 0 of square root of x plus 4 minus 2, like this. That's in the numerator. And in the denominator, I just have x. So once again, I can't use direct substitution because I'm getting 0 in the denominator. And as soon as I see that square root sign, I should immediately be thinking the third method, which is rationalize and cancel, because the square root sign is exactly when we would use rationalize and cancel. So what does it mean to rationalize? Again, you are multiplying by the conjugate x plus 4 plus 2 over x plus 4 plus 2. And what do we get when that happens? Well, we get the limit as x approaches 0. In the numerator, x plus 4 times x plus 4 gives us x plus 4, now without that square root symbol. The middle terms will cancel out with the square root of x plus 4 and the 2, and all we are left with is minus 2 squared, which will be 4. And then in the denominator, we have x times the quantity square root of x plus 4 plus 2. And again, what we're hoping here is that now something will cancel. So if we were to simplify, let's look at the numerator. X plus 4 minus 4. Well, if you look carefully, that's just going to be x in the numerator. Limit as x approaches 0. We're left with x in the numerator. And then the denominator, we still have x square root of x plus 4 plus 2. Hopefully you already see it. We have the x's here that are going to cancel out with each other. And then we are left with the limit as x approaches 0 of 1 over square root of x plus 4 plus 2. Well, now what do? We still have that square root sign. How did that help us? Well, remember, the goal wasn't necessarily to get rid of the square root sign, although that helped, especially for the numerator. The reason why we couldn't use direct substitution in the first place was because we were getting 0 in the denominator. Now, what would happen if we plugged in 0? Let's see. We would get 1 over square root of 0 plus 4 plus 2. And so 0 plus 4 is just 4. Square root of 4 is 2. And then plus 2. We're going to get a final answer of 1/4. And that is our final answer. So again, after you use rationalize and cancel, see if you can use factor and cancel, and then go to direct substitution. So it's almost like a reverse ladder in terms of you start with method 3, then go to 2, then go to 1. And so that's how you're going to solve problems like this where you need to rationalize and cancel. The next method, step 4, for the 5 ways to evaluate limits, are the trig limits. And actually, I'm going to take a break here and continue talking about the 5 ways in the next video. See you there.